Alright guys, so today we're going to be going through writing equations for linear functions. Alright, and first we're going to talk about linear function rules and how to get them from different situations. And then in the second video we'll talk about specifically slope-intercept forms. So let's go ahead and start with this. Alright, so a linear function rule is one whose rule may be written in the form f of x equals mx plus b. Now remember, f of x is just the same thing as y. So this is the same thing as y equals mx plus b. Now it doesn't necessarily have to look like that. It just needs to be able to be written in that form. And so essentially you've got a y, you've got an x, there's no squareds, there's no roots, there's nothing strange going on there. Right? No absolute values. It's just a plain linear function. All right? So let's look at a couple of situations and see if we can write a linear rule for them. All right? So here's one example. This is a common type. Is we've got a picture pattern. Okay? And you'll notice that each time the picture's changing slightly. Okay? So we look at set 1 here. Okay? So set 1 has 6, 7, 8 blocks. Okay, and then we go on to set number 2. So it's got 6, 7, 8, 9, 10 blocks. So set number 2 had 10 blocks. Set number 3 had 6, 12 blocks. All right, now you can see that each time what's happening? We're adding another 2 blocks onto the top. So that's the pattern that's occurring, right? So you could probably then predict for set 4 that you would need 2 more blocks. You can see the difference as well. The common difference, 10 minus 8 is 2, 12 minus 10 is 2. So assuming that the pattern continues, each time we need to add 2. And so we'll go up to 14, and then for set 5, we'll be up to 16. Now, in order to do the function rule, note that 2 is the slope. All right, and so we're going to write this in y equals mx plus b. So it's changing by 2 every time. And so because it's changing by 2, we talked about when we did tables before that the constant difference would be the slope as long as it's increasing by 1 each time. So we've got y equals 2x. Now we need to have a plus something on the end. Now, it's tempting to put 8 there because 8 is where we started. But if you put 8, then when the set is 1, you're going to go 2 times 1, which is 2, plus 8 is 10. So it can't be 8. This number, the number here, needs to be, what would it be for set 0? So we need to go back one more set to set 0, what it was before we added on the first time. And you'll note that if I go back one more, then it puts me at 6. So I go 2x plus 6. Now, just to kind of check that out, let's try one of the ones that we've done, set 3. Okay, so if I put 3 in for x, then it would be 2 times 3, which is 6, plus 6, which is 12. So it looks like it's working out okay. Now, using this function rule, I can now determine the number of blocks in the 6th set or the 234th set. Why don't you try that? And hopefully you get this. You went y equals 2 times 6 plus 6, and then you get 18 blocks for the 6th set. And then hopefully for this one, go ahead and pause it, work it out. And hopefully for this one, you got 2 times 234, which is 468, plus 6 would be 474. All right, so there you go. That way you can use patterns and a function rule to be able to figure out how many blocks are in any given set. All right, let's look at another type of pattern. We've got a number pattern. Okay, develop a table, write a function rule relating the term number to its value. So this right here is the first term. The first term was 18. The second term is 23. The third term is 28. And the fourth term is 33. Now you'll notice that each time what's happening? 23 minus 18 is 5. 28 minus 23 is 5. Each time you have a constant difference of 5. Note that the terms are going up by 1 each time, which means that 5 is the slope. And so we go y equals, and we're going to go 5x because that's the number that goes right there, the constant difference or the slope, Okay, plus, then we need to figure out what we need to add on at the end. Again, it's tempting to put 18 because that's the first number, but remember, just like in the last one, what we're going to need to do is we're going to need to take a step back and say, okay, what would the 0 term be? And we say, okay, well, the 0 term, well, if I went back one more step, 18 minus 5 would be 13. And so we're going to go ahead and put 13 there. We can check it out. If I put 4 in, that would be 5 times 4, which is 20, plus 13 is 33, which is what it should be. Okay, the next question is determine the 28th number in the sequence. Now that you have a function rule, that's actually very easy. If you didn't have the rule, then you would have to just sit on your calculator and go plus 5, plus 5, plus 5, plus 5, and then you would have to go back and make sure that you have the right number of plus 5s. It's quite annoying. So what we're going to do is we're just going to say, okay, well, let's just find the 28th number. We're going to go y equals 5 times 28 plus 13, and we go 5 times 28, and we get 140. And then we add the 13, and I got 153. Okay, so the 28th number would be 153. All right, now let's look at a graph, because we can get it from a graph as well. All right, so here we've got a graph. Now I still have my table. What do you think is going to go on the table? I'm still waiting for you to answer. What do you think is going to go on the table? Okay, so it's the points are going to go on the table because that's your x and y value. So I look at this point, it's 2, 11. All right, I go to the next point, that's 4, 5. I go to the next point, that's 5, 2. 5, 2. And I go to the last point, which is 8, -7. Now, I know what you're saying. You're saying, but 5 minus 11 is -6, and 2 minus 5 is -3, and -7 minus 2, I don't know how to do that one. I'm just kidding. It's -9. They're not the same. Well, yeah, they shouldn't be the same because these are not one apart. So even if they were the same, it wouldn't give us anything at all. It wouldn't help us. What we need to do, remember, this is y equals mx plus b. Remember, m is the slope. So what we need is the slope here. Now you can get the slope in many ways. You can do you can do m equals y2 minus y1 over x2 minus x1. You could do that, and so you could choose any 2 points. I'm going to choose the first 2 because they are first. So I'd go, this is point 1, this is point 2, so y2 is 5 minus y1, the y value of the first point, which is 11. Over x2, which would be 4 minus 2. So 5 minus 11 is -6, and 4 minus 2 is 2. -6 divided by 2 is -3. So there you got -3. You could also just look at the graph. You could just choose 2 points. It doesn't matter which 2 you do. You could go from here and you go down 1, 2, 3. So that's -3. And then to the right 1. And remember, slope is rise over run. So the rise over run would be -3 over 1. Which is, again, -3. You can do any points. You can do this one to that one if you want. You say, but that's going to be more than 3 over 1, Mr. Bauer. And then I say, yeah, but see, it's got to be rise over run. So I go 1, 2, 3, 4, 5, 6. It's going over 6. It's going down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So down 18. Okay, so I do rise, which is -18, over run, which is 6, and -18 divided by 6 is -3. All right, so now we just need the number at the end. Okay, so we need to figure out what's going to go on the end here, and it should be the y-intercept. Okay, so there's a couple of different ways you can go through it, but if you want, we're at 2 here, so I'm just going to go back to 1. So remember, I'm going to... It's a difference of -3, so I'm going to add 3, so I'm going to go up to 14. And then I'm going to go back to 0, which then would take me to 17. You could have also just looked at the graph and gone up 1, 2, 3 over 1, up 1, 2, 3 over 1, and that would put you at your y-intercept, which would be 11, 12, 13, 14, 15, 16, 17. So you can get it in many different ways. But counting back to the 0 is always one way of doing that. We'll talk about some other algebraic ways of doing it, but not for now. Okay? So, determine the x value when the y value is 12. This is now quite easy, right? You just put 12 in for y. So we go 12 equals negative 3x plus 17. And then you just solve, right? To get x by itself, we need to subtract the 17. So we got negative 5 equals negative 3x, and you divide by negative 3. You divide by negative 3, and negative divided by negative is positive, and you get 5/3. Say, but it's a fraction! Yes, it's a fraction. Live with it. Life is fractions. Leave it as a fraction. 5 over 3 equals x is perfectly fine. Okay, then it says determine the y value when the x value is 0. Well, when the x value is 0, that happens to be the y-intercept. Remember, y-intercept is when x value is 0. So we're going to go y equals negative 3 times 0 plus 17. And negative 3 times 0 is 0, so I end up with y equals 17, just like I expected, because we used the pattern in the table there. Okay, so that's just another situation where you can use the table, you can use a linear function rule, and you can see that the points were more or less in a straight line. If they're not in a straight line, please don't use a linear function rule. Please use the type of function that's appropriate to whatever type of graph it is. Okay, let's go on to another one. This time we got a table. Woohoo! A train is moving at a constant rate of speed. The table below shows how far it travels in a given number of minutes. Use the information in the table to determine how many miles the train will travel in 45 minutes and write a function rule. Okay, well, we're going to need y equals mx plus b. Okay, remember m is the slope. Now here, the easiest way to get the slope is to do what we were talking about before. To do m equals y2 minus y1 over x2 minus x1. And it doesn't matter which points you use. It really doesn't. You can use whichever points you want. So I'm going to do 10 minus 5. So 10, oh, so sorry, those are x values. So I'm going to go 11.5 minus 5.75. And then I'm going to divide that by 10 minus 5. Okay, so I counted this as 0.2, this is 0.1, so I did y2 minus y1 and x2 minus x1. And when I do that, I get 5.75 over 5, which equals 1.15. So that's 1.15 miles per minute, because you got miles on top, right? These are miles, 11.5 and 5.75 miles, and on the bottom we've got minutes. So when you get the answer, it's miles over minutes. Pay attention to the units. It'll be helpful to keep the units there and kind of pay attention, so that in the end you got 1.15 miles per minute. Alright, so that would be the slope. So we go y equals 1.15x, and then plus b. So remember, we're going to go back. We need to go back. Now, you can go by ones if you want. You can subtract 1.15 every time. Or if you notice that you're going by 5s each time here, it went from 23 to 17.25, which was minus 5.75. Sorry, it's plus 23 minus that. This minus this would be 5.75. This minus that would be 5.75. So this minus 5.75 would give you 0. So 0 minutes equals 0 distance, which I guess kind of makes sense. So by doing the constant differences again, I just did this minus this, this minus this, we were able to find out that every time time went up 5 minutes, the distance went up 5.75 miles. And so therefore we had our slope. We're also able to get the x-intercept, which is 0. And so now you can very easily get the time, or how many miles the train will travel in 45 minutes. Because you just put 45 there. And in the end, you should get 46 plus 5.75, so 51.75 miles. Okay, check it out. Make sure that you can get that number. And we're nearing the end. Alright, now continuing with the idea of linear function rules. Okay, given the linear parent function f of x equals x, determine the new function if x is doubled and then increased by 6. Okay, so we're going to take f of x equals x, so f of x, and we're going to double x, so 2x, and then increase by 6. Okay, so that's our new function rule. How is the graph of the parent function affected by the new function? Well, just remember that x was the original function. So essentially we have a 2 and we have a plus 6. Now, remember, with linears, it's much easier to just, unless there's a reason why we're considering it to be inside the function, we're just going to consider it to be outside. We had two rules. Anything on the inside of the function is done to x, which means anything on the outside is y, which is vertical. And then secondly, anything done to x is the opposite. Anything not done to x is exactly what it says. So this 2 is on the outside of the function, so it's going to be a vertical. And because it's outside, it's going to do exactly what it says. So it's being multiplied by 2. So if you're doing something vertically and you multiply it by 2, you expect it to stretch by a factor of 2. Okay, and then the plus 6 again on the outside, so it's a vertical. And when you add things, you expect it to shift up one by one. So a vertical shift up of 6. Compare the old and new y-intercept. Well, the old one was here at 0, right? And since it's at 0, when you multiply by 2, it's going to stretch the graph. These are being stretched up, these are being stretched down. 0, when it's multiplied by 2, it's the same as it was before. Now, when you add 6, when you increase it by 6, it means that everything is going to shift up. So the y-intercept, which was here, is now going to shift up to a positive 6. So the new y-intercept is at y equals 6. Compare the old, whereas the old one was at y equals 0. It's been shifted up. Now compare the old and new x-intercept. Okay, well, in order to do that, while the original x-intercept was 0, what's the new x-intercept? Well, we're going to find out. We're going to say, well, to get the x-intercept, I'm going to make y equals 0. So 0 equals 2x plus 6. You solve by subtracting 6. And so you get negative 6 equals 2x. Divide both sides by 2. You get negative 3 equals x. So it was at x equals 0 because that's where the x-intercept usually is for the parent function. It's been shifted 3 to the left. And so we've been able to create a rule which allowed us to then talk about these different things. All right, and our last question before we go on to really hitting the slope-intercept form. Mr. Crumb would like to have his calculators stacked. He asked his student, Darius, to stack them for him and to record the data. Determine the height of calculators for the following. Graph your data on the grid provided and label the x's appropriately. So what I'm going to do is I'm going to take my little calculator here, which you can't see, and neither can I because I'm just pretending. But I got my calculator here and I measure, and it says that one calculator is 1.2 centimeters. So we're going to go 1.2 for one calculator, which means that two calculators are 2.4 centimeters. Okay, so how do I get the thickness of 5 calculators? Well, I go 5 times 1.2, which will give me 6 centimeters. Now I want you to pause the video and try to come up with, as best you can, the height of the other 3 sets. Okay, ready, set, go. And this is what you should have come up with. You should have got 9.6. You should have got 12. And you should have got 18 centimeters for those. Okay, so we then can put that on our graph here. We go 2 calculators is 2.4. We go 5 calculators is 6, which is somewhere between 4.8 and 7.2. We go 8 calculators is 9.6. We go 10 calculators is 12. And then we go 15 calculators is 18. Just somewhere between 16 and 19. In fact, it's right in the middle of those two. All right, so we got some points here. All right, so we go on and we continue to ask questions about the same thing. Predict the height of a stack with 13 calculators. And so in order to do that, you would just take what you were doing before. Right, we had our graph 13. You could look at the graph if you wanted. You could say, well, this looks like a pretty nice straight line. You know, maybe let's just do that. So let's just make a nice straight line going through there. Do 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 do. Nice straight line. Do 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 do. How's that for a nice straight line? Okay, yes, it's fine. Okay, so then we look at 13 calculators, which looks like it's right here, which is right between 14.4 and 16.8. So about 15.8 0.6 centimeters. You could also take 13 and multiply it by 1.2, which would also give you approximately the same thing. 13 times 1.2, that would give us 6. 2 times 1 is 2. 1 times 3, so 13, which is 15.6. Okay, and you can do the same thing for 20 calculators, right? And hopefully you would get 24 centimeters. Okay? So just by using all the above information, write an expression to determine the height of a stack of calculators. Well, the easiest way to do that is to use your y equals mx plus b. Now if you go back and look at your graph, right, you can see that it has a y-intercept of 0. And if we look at the slope, well, your slope should be what it's increasing by every time. Okay, now you can do that in many different ways. You can do 2 points and do y2 minus y1 equals x2 minus x1. You could just count it off on the graph, like to go from, I don't know, this point to that point. I went up from 2.4 to 9.6, so I went up by 7.2, and then I went over from 2 to 8, so 6, so 7.2 over 6. No matter how you do it, you're going to find that your slope is 1.2, and your y-intercept was, of course, 0. And so there is your equation. And so now, if you were told that a stack of calculators was 55.2 centimeters high, you could just put that in for your height, and you could solve for how many calculators there would be. So, no problem. Should be getting kind of familiar, comfortable with the idea of writing these equations. We've done some of it in the past, and we're going to do more of it now. All right? So, that's the end of this first video set, and why don't you go on and try the next one?